students. Good evening students. Today we are going to start subject number 3, acids, bases and salts. Under this, in daily life we are observing so many substances in liquid, solid and gas states. Say for example, sugar, salt, what we are using in our kitchen room, water we are using is a chemical. What is a chemical? Salt is a chemical. And what do you call this one? What do you call washing soda is a chemical. Baking soda, you are using in the kitchen room is a chemical. Tamarindus, okay, turmeric. So if you see like this, so many chemicals we are using in our kitchen room. We are eating them. So at the same time, there are so many chemicals in laboratory they are using, and so many substances they are used in the nature. They are used by the nature itself, like carbon dioxide, like the chlorophyll, you can say, or you can say the salt. So many salts are there in the soil, minerals. All these are nothing but chemicals. Chemical means a substance has a specific properties, can react with other substances, can exist with some other substances, useful to the nature and useful to the surrounding. So that substance is nothing but a chemical. What we are eating, food is a chemical. What we are taking is a chemical. What we are taking, coffee, tea, all these are nothing but chemicals. Some chemicals we are getting from the living beings. Some chemicals we are getting from the earth crust. So some chemicals, they are synthesized in the laboratory. They are not directly available in the nature, but they are prepared in the laboratory. So like that, there are so many chemicals are present in this nature, in our surroundings. And all these substances, chemical substances, are broadly classified into acids, bases, salts, like this. So, first of all, what is an acid? Acid is a chemical, it is a substance, it is sour in taste. When you take just a drop of acid mixed with a glass of water, then try to taste. It is a sour in taste, like a imli, like a sour in taste, like a lemon, like a sour in taste. And it is a corrosive, means readily reacting with others. So that is the character of the acids. When you see the bases are bitter in taste. Same thing, base is also just to take a little bit a base and dissolve in water, try to test. Base is also a chemical. It gives bitter in taste, soapy to touch, and touch the base, it is a soap-like. But soap is also a base somewhat, so it is a soap-like touch, physical touch. So salts, already in our kitchen we are using sodium chloride salt, we are using baking soda salt, we are using, and washing soda salt we are using. All these are nothing but salts, like this. So like the turmeric powder we are using, and like this we are using the cabbage, is a purple color cabbage we are using, and beetroot we are using. So like this, so many flowers we are using in our daily life. All these are having certain characters, that is acids and bases characters, and sometimes they are the salts. Solid state, they comes under the salts. Okay, now how do you determine the acid solutions, base solutions and neutral solutions? Neutral is also present. Besides this, all these are neutral solutions are also present. Neutral salts are present. So now, how do you identify these things? We can identify by using certain chemicals. They are called indicators. Indicators means a chemical substance which is a weak organic acid or a weak organic base. Weak organic acid or a weak organic base. Its ions have one color and its molecules have another color. So what are you following? An indicator is nothing but a acid, is a weak acid, or it is maybe weak base. Organic weak acid, organic weak base. These weak acid, weak bases, they have one color, means a specific color in the ionic state and another specific color in the molecules state. So based on this property, we are using these organic weak acids and weak bases as indicators. So what is indicator? Indicator is a chemical. It is a weak organic acid or a weak organic base chemical used to identify the acids, bases, neutral solutions based on the based on the colors, which gives ions in one color and their molecules in another color. Okay, so these are called indicators. Now these indicator gives one color in molecular state, another color in ionic state. So these indicators are the weak organic acids or weak organic bases. Now these are again different types indicators. Natural indicators and second one is synthetic indicators. These are the different types. Again, under the natural indicators, you find one, litmus. So litmus solution is obtained from a plant is called lichen. A plant is called lichen, belongs to the Thallophyta. Belongs to the Thallophyta, division Thallophyta. It is a flowerless plant and it is used as indicator. When you prepare the solution from this lichen plant, it is a neutral state, is a purple color. This lichen is a plant, belongs to Thallophyta division, and in a neutral solution, neutral state is a purple color. So litmus solution is prepared from where? From the lichens. Prepared from lichens. The lichens nothing but a flowerless plant, belongs to the division Thallophyta. Its neutral state is a purple color. Now, this litmus solution is used for making the litmus papers. So these are litmus papers are two types: blue litmus and red litmus. Blue litmus, red litmus papers. Okay, blue litmus changes the acids to red color. when you put the blue litmus paper in the acid solution, changes to red color. So red litmus when you put in a base, changes into blue color. So like this we can, based on the change in the color, we can identify the solution is acid or base. So that is called litmus test. We are calling litmus test means when we put a litmus paper, either blue or red, in a solution, if the color doesn't changes, it is a neutral solution. If the blue color changes to red, that solution is the acid. If a red color changes blue, that solution is a base. Like that we can identify the acids, bases by using litmus solutions. Okay. Now, next one is the petals of flowers. Some flowers, so the colored petals of some flowers, okay, like hydrangea is one, petunia is another one, and geranium another. Like this, there are some plant flowers have different colors. They can be used, these colored petals can be used as indicators. These are the colored petals. Colored petals can be used as indicators. Colored petals can be used as indicators. Example, hydrangea, next petunia, another one is the geranium. So like this we are using, so here rose flowers with colored petals are there. We can use the indicators. Okay, now next one is the roots. Some roots can be used as indicators, like a carrot is a root. Beetroot, we can use the beetroot. We can use the turmeric. Turmeric is also a root. Okay, so these roots can be used as indicators. The roots can be used as indicators. Okay, next, leaves can be used as indicators. Croton leaves, like I know different colors are there. They can be used as indicators. Now, besides this, there are some other indicators are there. They are based on the smell. They are based on the smell. They are called olfactory indicators. Olfactory indicators. Olfactory indicators means the indicators indicates whether the given substance is acid or base based on the smell. We can get the smell with our nose so that we can say whether it is acid or base. That is called olfactory indicator. Now generally for olfactory indicator we are using onion, clove oil, vanilla. Like this we are using as olfactory indicators. So these olfactory indicators, one onion, how do you use onion as indicators? Now suppose turmeric is there, for example. Turmeric is comes under the root. The turmeric powder is a yellow color. When you put in a base, like a lime water, put in a base, it changes into red color. That indicates, so turmeric is yellow color. When add to a solution, solution changes to red color. That solution is a base. If the turmeric powder color is not changes, then you say the solution is a acid. If when you add a turmeric powder to a solution, it becomes a yellow color, remains as it is yellow color, that solution is a acid or neutral. Acid or neutral. If it changes to red, then it is a base solution. Like that you can say. Answer is A. So now next one is olfactory indicators. One is onion. How can you use that onion as indicator? So onion, first you chop this onion into small pieces and take in a polythene bag and take some strips of the a clean cloth strips. Put some strips along with the onion pieces and close the bag and keep in the refrigerator for about a day. Then take out from the refrigerator, freeze, and separate these cloth strips and wash the strips with a clean water. Then put these strips on a table. Then add on one strip, add a acid, another strip as a base, and you can observe the distinction. So where it gives a acid, put it acid, it gives a flavor smell. Where you put a base, it is a irritating smell. So acid with onion strip gives the flavor smell, and whereas base, it gives the irritating smell. So based on that, whether the given substance is acid or base. And another one is a clove oil. Clove oil can be used as indicators. When you put a drop of clove oil in a watch glass, then add acid and one watch glass, and there is a base. Then observe these things. You find that if it gives the irritating smell, it indicates it is acid. It is a non-irritating smell indicates the base. So like that we can identify the acids and bases. Now like that you can say vanilla. So vanilla you can find, if it is a slightly base, it is a good smell, flavor smell. If it remains, if that substance remains for a few days and change to acid, then you find it is a irritating smell. So not a good smell. So flavor smell indicates the slightly basic, non-flavor smell indicates the irritating smell, indicates the acidic nature. So like that we can identify the acids and basic natures by using the natural indicators. Understand natural indicators? Litmus solution, colored petals, some roots like a beetroot, carrot, and olfactory indicators. So like this, not only this, there are so many examples are there as a natural indicators. We are using nature itself. We are deriving these indicators from the nature directly. Now next one is the synthetic indicators. Synthetic means these indicators are the weak organic acids, weak organic bases. These are weak organic and weak organic bases. Two are there. And these are prepared in the laboratory by using chemicals. So these synthetic indicators comes under the one phenolphthalein, second methyl orange, methyl red, thymol blue. So like this, so many are there in this category, but we are taking the two things, phenolphthalein and methyl orange. Phenolphthalein, it gives molecule state. Molecule state is colorless. Molecule state is colorless, no color. But in an ionic state, it is a purple color or red color. You can say red or purple, no problem. Red color. So molecular state is colorless and ionic state is purple. That means if it is solution is a colorless, it is a acid, because phenolphthalein is a weak organic acid. Weak organic acid. So when it is a weak organic acid, phenolphthalein, when I put in a solution, it remains a colorless. Then it is a acid solution. If when you put in a solution, the phenolphthalein gives a purple color, indicates that is a base. So it gives a colorless in a acid solution. Acid solution. acid solution, and in a base it gives the base solution, it gives ions. So therefore in base solution it forms ions, it is a purple color. In acid solution it is not forming ion, in molecule state colorless. So colorless indicates the acid solution, purple color indicates the base solution. If color is not changing, it may be neutral. Suppose here colorless is there, the color is not changing, it is a neutral. Understand here? It may be neutral or may be acid solution. But if the ionic state is a purple color, is a base solution. It is a base solution. So like this, methyl orange. Now let us see the methyl orange. Methyl orange, again, molecular state is a yellow color. Molecular state is yellow color, and ionic state it is a red color. So yellow color, it indicates, molecular yellow color means it is a base solution. And in a ionic means acid solution. Why? Because methyl orange is a weak organic base. Since a weak organic base, it remains a molecule state in the base solution, so it is a yellow color. And it changes ions in the acid solution, so it is a red color. So methyl orange gives red color means acid solution. Methyl orange gives yellow color, it is a base solution. So like this we can use the two indicators to identify the acid solutions and base solution based upon these two indicators. These two indicators are the phenolphthalein, weak organic acid. Methyl orange is a weak organic base. Okay. So now these two indicators gives one color in the molecular state, another color in the ionic state. You know, here is a molecular state colorless, ionic state is purple color. Here molecular state yellow color, ionic state is red color. So here colorless means acid solution, ionic state means base solution. But here yellow color is a base solution and ionic red color is a acid. So like this, based upon the colors of solutions, we can identify the acidic nature and basic nature. And if the colors doesn't changes, it is a neutral solution. So that not only that one, these are used to identify the end point of the neutralization. Means when acid base combined together, mixed together, acid losing the properties with base, base losing properties with acid, both are losing their properties. At a particular point becomes a neutral. After neutral, just it crossing by either increasing acid, it becomes acidic solution, or by adding a drop, increasing base, it is a base solution. So that end point can be identified by using these indicators. So these indicators not only identify the acid basic natures, but also used to identify the end point of the neutralization. Means at what point both acids and bases are losing their properties. That is the character. Now acids are sour in taste, they are corrosive. Bases are bitter in taste, they are soapy to touch. And the salts are also, you find some acidic salt, basic salt, neutral salts, like that. Here acids, bases and neutral solutions. Like the salts also, acidic salt, basic salt and neutral salts. Same thing. So these things can be identified based on certain chemicals called indicators. Certain substances are called indicators. Indicator means a chemical substances which are used to identify the acid, bases and neutral states. So for that, these indicators gives one color in the molecule state and another color in the ionic state. So weak organic acids and weak organic bases are used as indicate generally. Weak organic acids, weak organic bases are used as indicators. Now these are the natural indicators. Synthetic indicators, two types are there indicators. Natural indicators means the indicators we are getting from the nature, from the living beings. And synthetic indicators are prepared in the laboratory, prepared in the industries. Now on natural indicators, again you come to another litmus solution. This is prepared from the lichen solution that belongs to the division Halophyta, flowerless plants. And here the lichens, so the litmus solution neutral state is a purple color. Neutral state is a purple color. Next, colored petals of some flowers. The colored petals of some flowers can be used as indicators. These are the, what do you call, can you give an example? Right, now see this answer is geranium is example, geranium is example, petunia is example, hydrangea. These are the examples of the flowers. Not only that, you can say rose flowers are there and sunflowers petals you can use it like that. So some roots can be used as indicators, like a beetroot in a purple, deep purple color. That solution can be used as an indicator, and the carrot solution can be used as indicators. Turmeric solution can be used as indicators. Like this, different. And next one is the olfactory. Olfactory means smell based on by using olfactory means nose. By using the nose, we can identify acid base based on the odor, smell. So these are generally, onion can be used as olfactory indicator. Clove oil means lavangam, no? That's a clove oil can be used as indicators, and vanilla can be used as indicator. These are all can be naturally obtained from indicators we can use. So synthetic indicator means prepared from the laboratory. There are different types. Phenolphthalein is a weak organic acid. Methyl orange, weak organic base. And methyl red, thiamyl blue, thiamyl red, like this, so many are there. But in our standard, we are using mainly phenolphthalein and methyl orange we are using. Phenolphthalein in molecular state is colorless, so that indicates it is an acid. Suppose we add a phenolphthalein to the solution, if the colorless solution, if the color not changing, then it is a acid solution. If I add a phenolphthalein to solution, it changes to red color, means ionic state is a purple color, then it is a base solution. Same thing. Methyl orange, molecular state is a yellow color, is a base solution, and ionic state is a red color, acid. Means methyl orange is originally weak organic base. When add acid solution, it breaks into ions. So ions means red color. If I add base solution, it again base, not divide ions, so it is a molecular state is yellow color. So yellow color indicates base solution, and red color indicates the acid solution. Okay. So these are the things we must keep in mind, how to use the indicators. Now let us see this one, some examples I am giving. Example is substances, you see HCl, H2SO4, HNO3. So you find these are the acetic acid. You find hydrochloric acid, sulfuric acid, nitric acid, acetic acid. All these are the acids. All these are the acids. These acids gives, one is red litmus, blue litmus, and phenolphthalein. Phenolphthalein, methyl orange, like this. So here the hydrochloric acid in red litmus. Any change? No change. Because litmus is red, is acidic, they also acidic. Blue litmus changes to red. Blue changes to red. Phenolphthalein is a weak organic acid, therefore remaining molecular state is a colorless. Colorless. But methyl orange, it is a red color in acids. Same thing, sulfuric acid, same point, red color, colorless, red color. And nitric acid, no change in the red and blue litmus, changes to red. Phenolphthalein, colorless, methyl orange is red color. Acetic acid is a no change, red color, colorless, and red color. Like this, you can identify the like this bases. Say for example, sodium hydroxide, magnesium hydroxide, and calcium hydroxide. Like this, you can find the all these are the bases. Okay, ammonium hydroxide. All these are bases. So these solution gives red color changes to blue. Red changes to blue color. Blue litmus, no change because it's a base. And phenolphthalein changes to purple color. And methyl orange becomes a yellow color. So this is the repeating for all these things. Same properties you can find. So this is the way you can identify this one, yellow color. So you can find all bases are giving. So red litmus changes to blue color. Blue litmus doesn't changes, no change. Phenolphthalein gives purple color. Methyl orange gives yellow color. All acids gives here. Red litmus no change. Blue litmus changes to red. Phenolphthalein changes to colorless. Methyl orange is the red because methyl orange ionizing. Methyl orange ionizing. Here phenolphthalein is not ionizing, it is molecular state. But in this case you find phenolphthalein is ionic state, methyl orange molecular state. So the colors remains constant. So like this we can identify the acids, bases and salts. For example here, take 4 watch glasses, and take the different solutions here. Here is the HCl, you find NaOH solution, here is a ammonia solution, and is a acetic acid solution, like this. So here you find, you just put the blue litmus. What happens? Blue litmus changes to red color. sodium hydroxide, add the red litmus, changes into blue color. But here, if we add methyl orange, what happens? If we add methyl orange, since it is a base, it is a yellow color. If we add phenolphthalein, since it is acid, it is a colorless. Like this, we can identify the acids bases by using solutions. Okay. Thank you. We can continue this tomorrow, remaining